Welcome back. In the part 1 we have seen that how we can plot the image, how we can load the image. There is one confusion in the part 1 that why this shape is 456 and 906. Actually this is not the shape of this single image, this is the shape of this complete grid image. The height is actually 456 and the width is actually 906. So this is clear now. So now let's move to the next section, that which model we are using and how we are passing the data to the model and how we evaluate the model and how we will pass the loss, how we'll get the loss function. So I am using ResNet 18 because it is a small model and I don't want to spend time on training. So I am using models.resnet 18. The model is basically in the torchvision library. I am calling from that. If I call the model and print you the model, you can see that the last layer of the model has 1000 neuron, but we want 1 neuron in our last layer. So we want it to predict between 0 and 1. So we want 1 neuron in the last layer because we have a binary problem. We can also get 2 neurons in the last layer, then we have to use categorical cross entropy. But if we put 1 neuron in the last layer, we can use binary cross entropy. So I have to replace this fully connected layer in the last with a new layer, so which I am creating it here. ResNet FC. I am using a new sequential model here. The sequential model will receive an n dot linear layer and a ReLU activation function after the linear layer and then another linear layer, which is actually the output layer, and it has 1 neuron. First I have to define that in my last layer there are actually 512 neurons. So I have to pass 512s to around 224 because I want a layer of 224 neurons or 256 neurons. So I will do ResNet 18.fc.inFeatures, which is actually 512. Let me display this here for you. We want 512 neuron to pass to 224 neuron, 224. Then we want 224 neurons to pass to 1 neuron. As this is a fully connected layer, so each neuron is connected to every neuron in the next layer. So 512 neurons are connected to 224 neurons and 224 neurons, each of them is connected to 1 neuron. So this is my model. So if I print this model, I will see that the last layer contains 1 neuron, output 1 feature. The next thing I want is to get prediction from this ResNet 18. So I will pass batch 1, which is actually images. If I print the shape of batch 1, it is 8, 3, 224, 224. Okay, I want batch 0 to pass, which is images, not batch 1, which is actually label. Okay, ResNet 18. So I have got 8 predictions like this one. We are not applying sigmoid activation function because in PyTorch there are 2 binary loss function. One is binary cross entropy with logits, which is actually BCE with logits loss, and one is without logit load. We are using BCE with logits that take probability instead of 0, 1. So next I define criterion. Let me make it also a big criterion equal to n dot BCE loss with logits. So next I am passing criterion to variable. One is the ground truth and other is the prediction. So first I will pass ground truth. First I will pass predictions, or let me Google that whether we need prediction first or we need ground truth first. I always mix that. So let me Google that. First we need inputs, which is actually prediction, and then we need target, which is actually the ground truth. Print, batch 1. Batch 1 is actually label. Or I don't have to pass it here, I have to pass it here. Now I know that when I run this code, I will get an error. So I'm running it to show you how you can solve the error. Okay, it says that target size must be same as input size. The shape of target size, let me print the shape of the target and shape of the prediction both. So you can understand that what this error means. Okay, if you see that the prediction shape is 8,1 and the target shape is 8, so we want prediction shape to be 8. So I will do flatten. So it will convert from 8,1 to 8. If I run this code, I will also get an error even now. Okay, they say that result type float cannot be casted to desired output type long. It means that I have to convert my output ground truth. It means that I have to convert my ground truth to float instead of long, which is integer. Okay, now I have got a loss of 0.7098. The next I have to use accuracy matrix, which I am calling from torch matrix dot accuracy, and I have to pass accuracy to variables. Similarly, I have passed to criterion and its predictions and labels. Predict dot flatten and batch 1, which is actually label. I am not passing float because it doesn't need that. Let me pass that. It shows that you got an accuracy of 0.5. As we haven't trained the model, so we can't expect it to be high. This is the second part of this series. In the third part, we will see that how we can use lightning module and create our own class and use the function of that class.